This video is focused on writing rational expressions. So the first problem we have here is write a rational expression with a hole at a specific point, in this case x equals 9, and a vertical asymptote at x equals -2. The way that you write something to have a hole is by making sure that it's going to be undefined in the denominator at x equals 9. So x minus 9 would be the way that you would write your denominator, because remember, your denominator is undefined at a hole. That's what makes it a hole. The second attribute of a hole is that weird things don't happen near it, only at that very specific point. Remember, if you have a hole, your graph is going along, choose my pen here, just going along no problem, and then at one very specific point, you don't have anything defined for it, and then it just keeps moving along like normal. So in order to make sure that happens, you make sure that your numerator is the same as your denominator. So for a hole, your numerator and denominator are the exact same thing, but in the denominator, it's going to blow up or cause a problem at that one particular value. In this case, we decided that it's going to be at x equals 9. And x here set equal to 9 would cause the denominator to go to 0. So what about a vertical asymptote? Same idea about the denominator blowing up at x equals 2, at x equals -2. So in order to make that happen, you would write x plus 2, because if you set x to -2 here, your denominator goes to 0. But the numerator in this case, you just leave as 1, because for an asymptote, you do want that weird behavior. You don't want it to, like the hole, just keep moving along like normal. When you get near the point, your function should go crazy and flip out and go straight up to positive infinity. On the other side, it might be coming from negative infinity and then go on and do what it does. So with asymptotes, you don't want to repeat your denominator in your numerator. So if you have to write a rational expression that has a hole and a vertical asymptote, you could figure out what your hole is, figure out what's going to make your asymptote, and just multiply them together. So the simplest equation in this case would be x minus 9 over quantity x minus 9 times quantity x plus 2. If you wanted to, you could throw in some constants in the numerator, maybe some other factors in there. You could add additional holes by putting additional terms on both the top and bottom. And all of that would still meet this initial criteria, but it has to have at least this as a minimum in order to be an expression that meets these requirements. This next problem here is a little bit different in the way that the question is worded. What it wants you to do is take a word problem and be able to write an expression from it. The way that I like to do problems like this is using something that in science they'll typically call dimensional analysis. That's where you look at the units that you need and you work backwards with the numbers you're given to find something that's going to make sense. So in this case, I think that starting from units is a good place to go. Just as a general tip, if you're ever going to take physics and you don't want to work too hard, get really good at this skill, because you don't need to memorize any equations if you can figure out what equations you need based on the units. Just a handy little tip. So, a rowing team traveled 6 miles at an unknown speed. So, I'm going to just write 6 miles, just so I remember that, and speed s. Let's go ahead, just so that I keep track of all the things that I'm looking for. For the final 4 miles, so we got 4 miles going over here, they traveled 5 miles an hour slower than their starting pace. So speed, whatever their starting speed was, we'll call that s, minus 5, because it was 5 miles an hour slower. How long did the race take to complete? So the answer they want needs to be a time. And let me just go back and see what the units were here. They traveled 5 miles per hour. So I'm going to actually write this as miles over hours. And same thing here. It's S miles per hour. That's what our units of our speed is going to be. We have miles, we have miles per hour, and we have a time. So I'm going to assume that time is probably going to be easiest to get in hours. So we're going to solve this for the number of hours. So how long did the race take? Some number of hours. In order to make sure that my final answer has hours in the numerator, I'm going to actually take the speed that we're given here, s, and I'm going to flip it on its head so that the units also flip. So the inverse of speed, I'm just going to write this out, the inverse here is going to be 1 over s. And the units on that is going to be hours per mile. All I did is I flipped this s, imagine it was s over 1. I flipped that on its head, took the reciprocal to get 1 over s. But when I do that, my units also have to flip. So now I have 1 over s hours per mile. So now I got my hours in the numerator, which is exactly what I wanted over here. Same thing here. If my speed was s minus 5 miles per hour, now I'm going to have, remember that was all over 1. So now I'm going to have an inverse of that. That's going to be 1 over s minus 5 hours per mile. So now I have miles, hours per mile, and I want to get hours. In order to make my miles cancel out, I can say if I multiply miles times 1 over miles here, my units are going to cancel out and I'm going to be left with hours. So I think that's what I'm going to try to do. We'll see how that works out. In the first part, traveled 6 miles at that unknown speed. So I'm going to take my 6 miles and I'm going to multiply that times the inverse of my speed, 1 over s, hours per mile. And this is going to be an amount of time. So I'm going to add that to the amount of time that I'm going to spend over on this side. This side I traveled for 4 miles. We got that from the original problem here. At a speed of 1 over s minus 5 hours per mile times 1 over s minus 5 hours per mile. And this all together here is going to equal the total time of the race. So let's go ahead and simplify this. Our units of, I'm going to change to a new color here. Miles are going to cancel out with miles here. Miles are going to cancel out with miles here. And if this all works out, we should be left with hours all the way across. Our final answer we're hoping will be in hours. We have hours just left here in the numerator and hours left here in the numerator, which means our whole thing is now in hours. So that's exactly where we wanted to be. So now let's simplify the math part of it. We have 6 times 1 over s, so that's simply 6 over s. Multiply our numerator, 6 times 1, that's going to be 6. Our denominator, imagine this is over 1, and so that's 1 times s is going to be s. Plus, what do we have over here? We have, let's call this 4 over 1, so multiply our numerators. 4 times 1 is going to be 4. 1 times quantity, s minus 5. You imply the parentheses because it's in its own fraction. So s minus 5. And that's going to be our time. And this is all in hours. So 6 over s plus 4 times s minus 5. It asks us to simplify the answer. So all we did so far is set up the problem. If we wanted to actually simplify the answer, that's where we take some of the other skills that we used and make this expression as simple as possible by getting a common denominator. Since there's no factor in common between s and s minus 5, I'm just going to simply multiply top and bottom of this by s minus 5, top and bottom of this by s, so that we have the common denominator of s times s minus 5. Sorry, these s's look a little bit like 5s, but these are s's, this is the 5. So let's try that out. We have 6 over s, multiply top and bottom by s minus 5. S minus 5 here. Plus 4 over s minus 5. And that's times s over s. And what we're doing here, we're just establishing a common denominator. So the whole thing is going to be over s times s minus 5. And that's our numerator. If we multiply this out, we're going to be distributing here. So 6 times s, we'll just call that 6s. And 6 times negative 5, we'll say that's negative 30. This is all plus. We have 4 times s here, so that's just simply 4s in the numerator. And our denominator, as we intended it to be, is going to be s times s minus 5. Since we have a common denominator, we can simply add the terms in our numerator and keep our denominator. So if we do that, we'll go ahead and write our denominator right away, so we have that, s times s minus 5. 6s plus 4s is going to give us 10s. Negative 30, and there's no other constants on this side, so just simply minus 30. And I see that we can factor out a common factor here. We can factor out a 10 on top. So I'm just going to rewrite that as 10 times s minus 3 is what's left over. And that is all over s times s minus 5. Now in this case, it looks like nothing simplifies or crosses out in the top and bottom, so this here would be our final answer for the expression that describes how long this race took. If we knew the speed in miles per hour that they started, we would be able to calculate it from this expression.